Hello, this is Britjet's PSX Tips, the Aerowings PSX 747 desktop simulation, and today continuing with videos on basically what are non-precision approaches, this time non-ILS approaches which are not in a database, so non-ILS, non-database approaches, otherwise known as Nindas. This video assumes that you've watched the 3 videos here as well to build up some background knowledge. If you haven't got a specific database arrival, you can still construct something. Go to the end of the arrivals listing and you'll find just the runways, and then selecting the runway you want, you've then got a choice of VFR approach or runway extension. Now VFR approach will then give you this option. There's a runway extension of 8 miles which you can't change, but you can vary the flight path angle from 2.4 to 3.7 degrees, depending on what kind of approach you think is likely, and the default is 3 degrees. If you then go, having executed that, to the legs page, you'll find something like this. The 2 waypoints will be joined up, the runway and the final approach fix, and the heights and the glide path are already put in for you. Now the height will be 2,000 feet above the runway itself. This particular airfield is 50 feet below sea level, so hence the 1950 feet there. And that approach can be flown with final approach logic, with VNAV and speed intervene. And basically what you do is you fly the aircraft down to 2,000 feet, fly it level, and then if you want to, you can fly the approach in VNAV from 2,000 feet. So the center line starts at 8 miles. Now the other approach over here, runway extension, is more suited to constructing a database type approach, which is very similar to what you see on the approach plate. And typically your runway extension here would be entered for the distance to the final approach fix. You put the distance in and execute, and then you get a display here which is slightly different to the previous one because there is a route discontinuity and there is no data on the right hand side. So join up the 2 discontinuities and then enter your own figures. Now you would enter these figures according to what is on the plate, but typically 50 feet above the runway at the threshold, and then whatever it says for your final approach fix. I put in 2,000 here, it could be anything. And the idea of that is that it will match what is on the approach plate that you have. Now the VFR approach is particularly useful if you're flying somewhere which hasn't got any aids at all, middle of nowhere, your aircraft's on fire. Here you have a system whereby the aircraft will actually fly with approach logic in VNAV. Runway extension over here, more suited to a non-precision approach where you are trying to build a database that is similar to an approach plate. This airfield in Azerbaijan has an NDB approach to runway 15, which is not in the FMC database. So let's see what we can do with the FMC to increase our situation awareness and help us fly the approach. If I select 15 on the FMC, I'm offered VFR approach or runway extension. I'm flying an instrument approach here, so I want to make what I put in the FMC tie up with the profile on the plate. So I'm going to use runway extension of 6.3 miles, which is about where the descent starts from the final approach fix from the threshold. Execute that, and if I check the legs now, you will see I've got a final approach fix and a runway. That's all. Join them up, and then we need to put in an altitude for the final approach fix and the runway. This airfield has a threshold height which is actually 50 feet below sea level. You need to construct a threshold elevation in the FMC which is about 50 feet above. So I'm going to put in just above 0, 170 knots because the speed must go in as well, and then 4 letters, and I'll put 10 feet in. And then similarly for the 2,000 foot point, which is the start of the approach at what is 7.9 DME there. I've now constructed something that can be flown in VNav, and I can also put in other points. For example, you see there's a point there called Lazier. Now it just happens that this is in the database, but if it wasn't, then I could also put that in as a fixed point. So now we've got something to tell air traffic control as well. Now there's two ways of getting on this final approach course here. One is a procedure turn, a teardrop, and the other is an extended hold. Let's have a look at the teardrop first. Now the teardrop goes from the lemur beacon, so I'm going to put lemur at the top, quite a lot of lemurs, and the course is 346 at about 11 miles for Cat D aircraft, and now I'm going to do it like this, lemur 346 11. Stick that in. I've now got a waypoint lemur 05, and you can see it on the map display there. Don't join up the route discontinuity. What we're going to do is fly the outbound in LNAV and then come round the corner in heading cell and then reactivate effectively the inbound course. The reason you leave the discontinuity there is if you put it in, it can confuse the map, and also you can get incorrect cycling going on, which means that you lose the inbound course in the database before you've actually flown it. So leave it like that. Great. So once we're coming inbound as well, what we can do is put an inbound straight in. So as I'm going round the turn, having left Lima 05, in heading, I would put Lazier at the top and execute it, and then select it down to the bottom again and back up, which enables me to put the inbound course of 146 on the 6 right button where it says intercept course, and I've now got a straight line in. And you can imagine coming round that turn in heading, arming LNAV, and then flying the whole approach in LNAV. Now this works fine as long as the runway is aligned with the inbound course within about 3 degrees. Outside that, you really can't do that in LNAV. So that was a teardrop. We could also make an extended hold that it shows here. So again, let's see, the hold starts from Lima. So Lima to the top and execute, and then hold at Lima. And the course is 146 left turns, so I shall put that in on the inbound course. And then all you have to do then is decide how much the outbound leg distance would be. I'm having a guess at about 11 to see what it looks like, and I'll put that in. And that looks pretty good. Now you've got a hold, which you can fly in LNAV, which will enable you to come all the way around the final turn in LNAV and onto the final approach course. Lots of other things you can do with the fixes, of course. You could use Lima in the fix page, like that, and just put the outbound teardrop as a course, like this, and that will just draw the line for you. Also, just imagine if they asked you to join a DME arc, which is not part of this procedure, but you can actually draw a DME arc. So the DME in this case would come from the ILS, which is in the nav radio page there. So in the fix page, I would put in the ILS, which is the India Lima Mike, like that. That now becomes a fix, and I can now put in slash and whatever DME arc I wanted, shall we say 12 miles. There it is. And of course any of the green lines can't be flown in LNAV, but you could drive yourself around that curve using heading all the way round onto final approach in LNAV. So LNAV is king here. It works extremely well. Heading is also an option. As far as the vertical profile is concerned, it can be flown in VNav, but you might have put something incorrect in there. Always use raw data, and the recommendation really for an approach like this, where you haven't got a glide path in there as 3 degrees or something like that, the recommendation is to fly the approach in VS, and we'll be doing that presently. Let's fly a Ninda approach NDB 34 right at Izmir in Turkey, and we are on about a 14-mile final. I've just positioned us here. We're going to join everything up and fly a Ninda approach in LNAV and vertical speed. We are at flap 10 configuration, flying at altitude hold. It's a fairly steep approach, so I'm selecting flap 30. In the fixed page, I've put a ring around 12 miles from the VOR, which gives me a descent point. On the NavRad page, the VORs now have to be tuned manually, because there's not a database for them. Always the ADFs manually. ILS is deselected, and I've put 315 in as a go-around NDB. I've got the Mike Echo pointing on the blue and on the left, and I've got Mike Echo November DME on the right. Okay so far. So let's put the approach in. Now you'd already have done this of course, but I'll show you what we're going to do. So there's lots of database approaches here, but let's ignore those. You can do this for any airport. Go to 34 right, and I'm going to put in 4.9 miles as my extension, which is where the Mike Echo final approach fix is. If I go to legs and join them up, and then I can put in my constraints. The threshold first would be, it's about 370 above sea level, so add 50, 0420, and similarly for the Mike Echo, which is 2100. Execute those. Now I've got a magenta line, and in fact I can extend it all the way out by selecting FA34 right up to the top and putting my course in. So there we go. I can go LNAV all the way now if I wish. Now the rest of the approach starts at 14 miles by Boeing recommendation, because that is about 2 miles before the descent point. And they recommend that you start configuring then. Last bit of housekeeping is to get the aircraft ready to go on the autopilot. So select vertical speed to 0, and it's important to wind the alt cell down to the first constraint, which in this case would be the final approach fix. If there isn't a final approach fix as such in the way, then you put in the MDA. So we're ready to go. I'll let the aircraft run and I'll engage LNAV, and we are on our way. About 2 miles to run then. What I will do now is select the gear down, flaps 20, and start configuring the speed of the aircraft, ready for the approach. The idea is to have the landing checks completed before you start down. Now with about half a mile to go to the descent point, select your landing flap and ensure the checklist is complete. So we're at 12.9, coming up to half a mile now. I will select my flaps to 30 in this case, speed back ready to go, landing checks completed, and what we need to do now is start down a little bit early, 2 or 3 tenths of a mile early, and the idea now is to get to 2100 feet where we get to FA34 right. There are various ways of doing it. The vertical path pointer is the most reliable. You can also use your green arc, although that might wave around a bit in turbulence, and the DME checks should be quite useful to you. So the DME checks off the plate at 10 miles, I'm looking for 3450 feet, and I can see I'm a little bit low, so I'll slacken things off a little bit. Now on any of these approaches, it is most important on the final approach phase that you don't get high. If you're low, you can usually recover the situation, as long as you don't hit the ground of course. If you're high, there is very little that you can do about it. So DME checks continuing, 9 miles I'm looking for 3120, and I am a shade low, so I'm actually quite happy with that. And we will continue on down. We have to wind the alt cell further down or we will get an altitude capture. So when I'm happy that my range ring is where I want it, I will select my MDA in the alt cell. Now the glide path angle that you're maintaining now may or may not be suitable once you pass the final approach fix. So it's important to make sure that you are changing the vertical speed as necessary on the way down. A DME check as we go past 7 miles will tell us how we're doing. we should be at 2440. Pretty good. I'm happy with that, but I'm going to give me another 100 feet a minute because I'm like that. And the green arc now can remain in place even after you've passed final approach fix and 300 feet below. Boeing recommend you keep it there until you're 300 feet above your MDA to give you some guidance as to where you'll be leveling off. How late you leave it is up to you. You might well be busy. So we're coming to final approach 34 right, and I'm a shade low. So I'm going to back off the rate of descent slightly. And the DME checks are important now. 5 miles, I'm looking for 1760. And that is pretty well spot on. So we're approaching 300 feet above MDA, so I'm going to wind in my go around, most important to do that, and continue to do my checks. And as we approach our MDA, we are hoping to see the runway and take over visually, which would mean taking out the autopilot and the auto throttle as appropriate and flying the aircraft down. So that's the non-precision approach. Hopefully the runway is appearing. If you're looking out the front of the window, notice it's important to make sure you've got the right runway. You can probably see 3-4 left out the left window as we go there. That is not the one we're going for. We're going for the one which is underneath the central partition. So that's a Ninda approach. The VFR approach option then, well, 747s don't typically fly along on visual flight rules, although they can be useful for certain airfields. If a large airport asks you to fly a visual approach, the chances are there'll be an ILS at the back of it, so you can use that. But if all else fails, the VFR approach is an option. And as I said earlier, this can be flown in VNAV with speed intervene. A really useful way to use this approach is, however, if you find yourself suddenly having to go to an airfield with no aids at all in the middle of nowhere. You wouldn't choose to go to Taiz in Yemen on your holidays, I'm sure, but you might well do it if your backside was on fire. So here we are pointing at Taiz. We're not going to fly the approach, I'm just going to explain what happens. You can see on the FMC there are no approaches available, but if I go to 01 as my chosen runway and select VFR approach, I will give runway extension of 8 miles. I choose my own flight path angle, which is 3 degrees. I'll stick with that. And if I go straight to legs, it's all there ready for me to go, and I can fly that in VNAV and speed intervene. One point about this, the final approach glide path of 3 degrees starts from 2,000 feet above the threshold. So there will be a level flight phase 2,000 feet above the threshold, and then the aircraft will start down on 3 degrees. Speed intervene, VNAV, LNAV, exactly what you want if your backside's on fire.